Right, set the topic for the today. We'll be focusing on the trigonometry. Remember, we did trigonometry in grade 10, and then in grade 11, and now we're in grade 12. So with the grade 10s, we're not yet done. That's why I call it the grade 11. So on the grade 11s, we're far apart. So we're going to repeat what we have done with you, the grade 11. So it means it's your opportunity to hear that information again. So if you hear well, it means now we're going to grasp more information about the trigonometry. So now, looking at our trigonometry, of course, they can expand it or give it the definition. Now, the trie, all know what is meant by the trie. Again, what does it mean? Simply means what? It means what? That simply means three. Again, the trie means three. And what about the gone here? What does it mean? What does it mean? So this can simply mean the sides or the shape again. And then we also have the part of the metric. This, what does it mean? It simply means we can say the measure or the measurement about that. So what does it mean? It means now we're going to take the three-sided shape and then we measure the angles. So now it means the trigonometry is about the measuring of the angles and the sides. So in fact, it's the relationship between the sides of a triangle and the angles. So it means we'll be dealing only with what? The triangles. And then with the triangles, we want the relationship between what? Between the angles and the sides again. So that is only about that. And then in this trigonometry, we are only having two definitions. Then we'll come across that. But before that, we're simply going to do what? We're going to do only the triangles. Is that difficult? And then there are a few triangles that we mentioned in the lower grades again. Remember, you're doing the types of triangle in grade what? 6 or 7. Even so on the lower grades there, but somewhere starting from grade 6, I'm sure there are triangles. Remember, you started to color the shapes in crash. You were coloring the shapes. You knew the shapes. So this is a square, this is a triangle, and then you are coloring them again. But now, just imagine you are suffering from the triangles only while you are in grade 11 and 12. So that is not good. So it means what you have to do, you must make sure that you just grasp the information. All right. The first part that we're going to do in grade 9, we're doing more on this one. And then having this part, what type of triangle is that? So you were doing right-angled triangle again. How do you see that is right-angled triangle? What do you see? There is a 90 degrees here again. So one angle inside the triangle is 90. So simply means that is a right-angled triangle. And then you did the type of the angles again. What is the name of this angle? That will be an acute angle again. Then what is an acute angle? What do you know about the acute angle? Anyone? Yes, at the corner. Angle that is less than 90 degrees only. We end there. And acute is it angle that is less than 90 degrees and we end there. Remember, if you are saying the angle is less than 90 degrees, Is there any stoppage when we're going there? Or you can go up to negative? So you must be careful how are you saying the definition, okay? Because if you just say less than 90 degrees, those that understand better, they'll be confused. Oh, it means I can go to 0 and pass the 0 and go to the negatives. So it will end up opening to be more than 90 degrees, okay? So it means it must be having the limit. So what is the proper definition? What do you say? It's almost 0. Is it starting from 0? Or is greater than 0 but less than 90? Which one is the correct one? Are say it. Less than and not more than is kind of the same thing. Is less than 90. If you are less than 90, you cannot be more than 90. So of course, agree this is the line, and this is the line of 0. Maybe let's say 0 degrees. Then I want to make an angle with this line. So can I stay here and I say this is an acute angle? So what should happen from this 0? Then we must start counting again. When we start counting, anything that is, we remember when it's here is 90 again. So any angle, remember, will be moving like this. Any angle that is playing within more than 90 degrees again, within 90 and 0, playing within, then that will be what? That should be an acute angle. Not, rather that angle should be between 0 and 90 degrees again. Not less than not only less than 90 degrees, but between 0 and 90 degrees. That should be there an acute angle. So okay, that will be the angle here again, or there will be the angle here. Both of them must be an acute angle. So now, before we get further into naming the triangle, we used the Greek words that we used to define our angles again. Which ones that we remember? The symbols of those Greek words. Theta, alpha, beta. Those are the popular ones that we know again. That we can use them to denote our angle. Those are the special symbols that we know that when we see the theta, we'll be seeing an angle in trigonometry again. An angle is measured in degrees, nothing more, just degrees. So any number that you write that is not showing that is a degree, then you'll be confusing people. What is it? So you must show. When I see theta, you know that is a certain degree. Okay? When I see alpha, you know that is a certain degree. When I see beta, you know that. Okay? But if I come here and write 5, will you say it's an angle? So it should be 5 degrees. So 5 can be the sides, can be the length, can be anything. So you must be careful of that, what they mean. Okay? And then you did the special property of this part in grade 9. What do you know? What more do you know about this right angle triangle? If this is an acute angle, and here's an acute angle. So what angles this could be? Let's say this is theta. Can you know this angle? How? Yes. Yeah, you can raise your hand and see if you know the stuff. Can you know that angle? Yes. So what is the axiom about this, or the agreement, the Greek definition about this, or maybe the theorem of this what is the theorem of this triangle about the angles? We're saying this angle is here, in here they add up to. What is the another word for that angles are adding to 180 degrees? Very good. They are the angles of a triangle. They are supplementary. So be alert of the word supplementary. So Skadziva only adding to 180 degrees. That is equivalent to supplementary. Again, when you say the angles of a triangle are supplementary, yes. If you are saying what? Not only right angle triangle, but every triangle. Some angles of a triangle. That's when we are reasoning in the other part again. But now we want the specific word. What are they doing? Because we cannot just say some angles of a triangle. So you must be specific that they are supplementary again. I'm saying when I say it here, when I'm explaining to people, or when you are doing the Euclidean, yes, you can say that. But you are not yet at the Euclidean. So let's say the proper things that will make sense again. Yeah. So now you're saying we can know this one. So meaning maybe let's label the triangle. Let's say it's A, B, C. Kana, if that is A, what is A meaning? A meaning that will be an angle. Again. Why is it an angle, or what is the definition of an angle? Yes. What is the definition of angle? Just not an explanation, not strictly definition, but an explanation of an angle. What does it mean? Arek. The grade 11s, I told you what is an angle. Arek, yes. A number that can be measured in. Are we measuring the numbers? So what is the angle? Yeah? Yes. The angle is just simply the space between two lines. Again, that space between two lines that will give us an angle. So we must know what is an angle, because we just saying angle. At the end, we are going to write some miracles here and say it's an angle. So that is the space between the two lines that will give us an angle. If you observe here, this is the space between this line and this line. That will be an angle. Here, this is the space between this one and this line. Okay? Here is the space between this line and this line. This one, you can see that the spaces between the two lines are called the angle. All right. Now, looking at that part, that is the space between that. Now it's fine. This can be called, if we are saying we want to name it this point, we're calling it a vertex again. But when we get inside the triangle, we call it what? That would be an angle. But this corner, we just say it's a vertex, or it's just a point. But when we want to name it in terms of the inside of the triangle, we can name it an angle A. Again. So, but angle A, but once I put theta, it means that angle has been given. But if it's like this, that angle is not given there. It's just angle C. But once I put something there, it means that angle is being given. As what? As theta or alpha. But now you know that this is a certain degrees. Then you know that. So the x or the whatever thing in place of the angle or against it means we have that. Okay? So note that we are given that information. All right, we were saying the sum of these angles of this triangle is what? Is supplementary or 180 degrees. So what simply means angle A plus angle B plus angle C equals to 180 degrees. Okay? But now we are given this angle A. Okay? What is it? It's theta. Okay? We are given this angle B. What is it? 90 what? 90 degrees. Okay? Plus, now we don't have angle C. But we know that when we add them, they will give us 180 degrees. Then now, what you do here, we have to do your algebra part. So right, we are only looking for C. So you know that we must put the additive inverse of these things again. So when we say additive inverse, now we're no longer saying many things. We know that we're going to transpose. Now we're not going to a jumper equal sign. And now now you're changing your status again. So change your status if you will rati or radika not on the other side. So now we're going to change your sign again. So even this side, this one is going to change when it goes on the other side. But the correct way is what we're saying is the additive inverse of those ones again. I mean the additive inverse, we must bring someone with opposite sign of which is the same again, but the same magnitude but opposite sign. So, but we do it in our own way, saying that will be 180 degrees, then the theta will go. Or let's take 90 first to be negative 90 degrees again. Then this will be negative theta. Then now the angle C is how much? 90 degrees. Oh, it means you can also know this angle. Let's get it. So it means what do you say? This angle will be 90 degrees minus theta. Any question? All right, now, yes. Yes, it's correct. But now here again we have to say some angles of a triangle. So that now you understand your stuff. Even if you said angle C equals to 90 degrees minus theta, so you must put that is the sum angles of a triangle to show that you know what you are doing again. But what I want is that you must make sure that you don't do the mistake along the way. Because if you don't write this and do the algebra, you might lose the focus again. So here is just to bring your focus on so that you can do step by step. Otherwise, it means we're going to have an issue if you get it wrong here. So make sure that you do what you understand again. All right. Now it means we know that all the angles, this angle and this angle. So now everyone can define or know the angles of a triangle again. If you have two angles, you can see that we can get the third one. So be alert that in every triangle, if you see two angles inside, it always can know. It doesn't matter whether it's a right angled or not right angled triangle again. So you can know the third one. But now I want to talk to these two angles here, and you tell me what you note. What if I add these two angles? This one, angle C and angle A. What will they give me? 90. So even for 90, always in a right angle triangle. These two angles, because 90 plus 90 is how much? So these two angles, already this one is booked 90. So these two angles, they always give me what? 90. There is no way they cannot give me 90. Is that clear? So now, if they always give me 90, what can we say about that? What is the name of the angles that are giving us 90 degrees when we add them together? Yes? They are complementary angles. Already, the two angles of a triangle, they always be complementary. Meaning that when we add them, they'll always give us 90 degrees. So, and if you know that they'll always give us 90 degrees, so if I know that is 30 here, 30 degrees, what will be the angle there? You see that you can subtract that from 90, you get the 6. So don't be confused or about how you'll get the other angles. They are always complementary. And then now we're going to remember them. We're going to bring them along the way about the changing of the two functions. But we'll see it. Let me not mention it now. All right. From here now we are happy with the angles. let's go to the sides. Now we know we can name the angles. Now we need to name the sides. So let's take the same triangle and put it here. A, B, C. Okay. Now on this ABC, we know this is 90 degrees again. And then we said this will be theta. And then we said this will be 90 degrees minus theta. Of course, it's not if one feel a fella, but sometimes they can decide during this is what? This is alpha. Is there this here? But we know that alpha is still a certain degrees again. What are they? Still, let me write it here. If one feel this one, but this is theta alpha, this is theta and 90 degrees. What will be the value of these two when we add them? They will still be 90 again. So I was on 90 minus or 90. So automatically you know the rule that in a right angle triangle, the two angles that are remaining that are not 90 degrees, when you add them, they must be complementary. So that this alpha plus theta, they should be 90 degrees when you add them again. So that is the thing. Alright, now we are here. We want to name what? We want to name the sides now again. Now in a right angle triangle, we're always having one side that is bigger than the two. If you did your maths properly in the lower grade 7 up to now, you were doing this by measuring the sides again. You're using the ruler and you're measuring the sides, and then you're measuring the angles. But when you measure them, you'll always see that this side that is opposite. What do you mean by opposite? Or opposite gathering the opposite of this one, of this angle. Now can you see that we are giving the relationship between the angles and the sides? Because now when you say the opposite, you must be having a reference. Because not opposite anywhere. Okay? So opposite of what? So when you say opposite, you must reference something. Okay? Unless if you are sharp, go to the opposite. Which opposite? So you must tell me the direction. Okay? It depends on where you are. So now this angle is 90. In that way. Looking at that directly, then we say is the opposite side. Okay? But now, because this side is bigger, we agree that this side of triangle that is opposite to 90 will always be bigger. Okay? So now, once it's bigger, we call this the. Do you agree with me? Some other things are just the definitions. We have to take them as they are. Okay? But you understand that every side that is opposite to 90 degrees, it will be what? It will be the hypotenuse. It will be named the hypotenuse. Again, is there any side that is bigger than the other ones? We are not sure yet. Again, but this one we are sure that is always bigger than the two. Again, hence you did the Pythagoras theorem in grade 9. You still remember it. Okay, we will require it at some point, but we'll talk to it. All right. From there, after the hypotenuse, now we are having the two remaining ones, the opposite and the adjacent. Again, so which side there will be the opposite? You're buying BC, CB. How many are saying BC? Now you see, you are starting to get it wrong. I said which side will be the opposite, and then you cannot know the opposite without the reference. Okay, opposite way make up. Yeah? So when I say which side will be opposite, we must say opposite of what? You need the direction, again. So the vertical side is not always the opposite. Okay, it's fine. Was saying vertical? Yes. Now the key is that the vertical is not always the opposite. It depends where you are. Okay? Then that's when we say the opposite. Is that clear? So now, let's see. Now, please note that you cannot say for yourself. Always the vertical will be the opposite. That is not correct. Okay? Because the opposite I said is the one that you are looking at directly. Okay? So rather, if you are here, this angle is looking this side directly. Is it not the opposite? I said opposite now. This one, I said opposite because we're saying the opposite is where you see the side directly. You put yourself at the angle and you look at it directly. Then what you see there is the opposite. So let's not say there is opposite without a reference. Alright, when I say opposite, you must put yourself somewhere again. Therefore, you can say that is the opposite. Alright. So it means when I say which one is the opposite? Opposite of what? Now I tell you what is the opposite of theta. Which one is the opposite of theta on that triangle? That will be BC, which means this will be the opposite side of what? Of angle theta. Is that clear? Alright. Now, what you can say about the opposite? Of course, the opposite will be the line connected to 90 degrees. Okay? The line should be connected to the 90 degrees, can be the opposite. And there are two lines connected to 90. You know? This AB and that one. Is that clear? Now, the adjacent or the theta or the angle, is the base of that, again. Is the base of that. So that will be the surface of this angle. So obviously it's this one again. So this can be what? The adjacent side of angle theta. Is that clear? Now we're just naming the sides. We're just naming the sides. Now, what is the opposite of this one? Of 90 minus theta? Is what? AB. So can you see this side can be the opposite, but not opposite of theta. Opposite of 90 minus theta. So this is the opposite. So you must know where you are before you say the opposite is this one. So now looking at this 90 minus theta, which one will be the adjacent of that angle? Which one will be the adjacent of that angle? 90 minus theta. That will be BC. So that will be, because if you have to turn it around, you see this side will be sitting on this side again, or this angle will be sitting on this side. So meaning that will be the adjacent. So of course, a side cannot be opposite and adjacent at the same time again. Hence, we're saying we must give me the reference. Where are we? So that we can say that is the opposite again. So rather, be careful when you're talking about theta, that will be opposite. This will be the adjacent. So that is the relationship between this theta, this angle, and that side. Okay? These are opposite. This is the relationship between this angle and this side. They are, but you can see that the hypotenuse is fixed. How is it fixed? It's always opposite to the 90 degrees. Any question? We can move on. Okay. So it means no one will do that mistake along when we're answering the questions about the opposite and the adjacent. Alright, now after having this one, it means we can bring out the definitions. Maybe let me now just change the direction of it. Okay, this will be C, D, E. And then of course this will be theta. And if that is the case, Now we want to define the sine. We have our trig ratios again that are there, which means trig ratios, or let's say we have the trig functions where we can be determined in terms of the ratios depending on the right angle triangle. So these definitions are given based on the right angled triangle. So they are applying only on the right angled triangle because they are defined based on the right angled triangle. Again, so if you have theta here, we have before that we can have the sine of theta. So remember we talked about the angle and their relationship of the sides. Okay. Now we're saying the trig ratios now, or the trig functions, they are defined in terms of the ratio of the sides. Okay. So now it means when you are saying the sine of a certain angle, we must define it in terms of the sides because that angle is related to the sides. It's having the relationship with the sides. Now they are saying the relationship between of the side, definition of the sine is saying is the opposite. Now I'll use this for the opposite again, over hypotenuse. This is the what? This is the definition of sine based on what? Now we're going to define it looking at the triangle. What will be again in this case? But this will also defined using the right angled triangle, not anything but the right angled triangle. So now, if that is the opposite over the hypotenuse, now it means our sine based on the theta can be written as what? You're buying over which side over which side? Yeah? CD over is that correct? CD over, what does it mean? It means when you are here, the opposite side is what? CD. And this will be the hypotenuse side because it's opposite to 90 degrees. Is that clear here? That would be the definition of sine of an angle inside a right angled triangle. I'm saying right angled triangle. Don't be more excited and use it anyway. So look at your triangle if it's right angled triangle. All right. Now after that one, we have the definition of the cos of. Now there is no function without an angle. That function of course without an angle does not exist. Okay? You must make sure that it is an angle. All right. From there, they are saying the definition of this one, the cos is what? Is the over hypotenuse. So based on this triangle, what will be the answer? DE over CE. Is that clear? Now let's go to the tan of an angle is defined by what? Opposite over adjacent again. So in this case, it will be what over what? So the tan of theta will be CD over DE. Is that correct? All right, now, for you to not forget that, because some people can find it many, you know about, you can take this first letter here and take second letter there and the third letter there in that order, knowing that this will be the function, this will be the first side, this will be the second side. Okay, so what does it build? Yeah, it will build this one again, and then now you can come here again, you take this one and then you take this one and this one. What does it build? And then again you can take this one and take this one and take this one again. Then what does it build? So you always know that is the function. This is the first side, that is the numerator, and the denominator. What? In that case. So but we started by defining this one, going to this one, and ending with this one again. So what this can be studied by, you all know this song again. So don't be shy of writing that down when you are answering your trick, because it's your weapon. If you are shy, you think you can do it in your head, you might confuse things. So write it down, make sure that you see what you're writing. Some people are shy of writing what they know, feeling like they are fool, maybe if they are writing soccer show. So you're not a fool, you are making sure. Alright, so every time when you see right angle triangle, you can you remember that definition again. So there is no this definition without right angled triangle. Right, any question? According to what? Ukasongale. This one. There is no angle. What is this one? Well, as well as we put, if I put x here, we know that x there will be waiting for that angle. So we agreed at the beginning, maybe you're late, that we know that this is the Greek letter that are showing that it's a must to have what? To have the degrees. Is that clear? So we said once you write this, you know it's a degree, nothing else. Is that clear? All right. Now let's move on to the next part. I wanted to see something, because now I'll bypass something here, but I hope you'll be with me on this one. All right, we said what will be this angle? What will be this angle? 90 degrees minus theta again. Now I want you to observe something. You'll see if it will make sense. Okay, and you'll see it somewhere along the way. All right, let's write it in terms of that. So what will be sine into 90 degrees minus theta according to that? Yoba? Yeah? D E over C E. Again? Alright, what will be? Let's write going down. Cos of 90 degrees minus theta. Right, then cos of 90 minus theta, what will it be? Yoba? C over CE. Agree when if I say cos of this, you put yourself on the cos, okay? Okay, my cos I know is the adjacent, and you put yourself on the diagram here. It's saying adjacent. Which one is the adjacent here? You see that is this one again. CD. Then over the hypotenuse, you know is CE. Alright, so now let's go to top. We will finish that, then you will go for a star. Now what do you have here? Yoba? I said your weapon is soccer throw. You cannot look at me and say you want to, or look at that diagram only. You look at the diagram, okay, I'm here. Now, what is Tan saying? Now, I'm here. I must start by what? Opposite. So I'm here. The definition says I must say go opposite. Opposite is what? Then is DE. What? Then you come say, okay, the next one is what? adjacent. Now, what is the adjacent of this one? What is it? You know that is CD. Now, I want to show you something before we go to, I'm sure some they just know it with another name, but they don't know where it's coming from. All right, let's look at the two. This one for theta and this one for 90 minus theta. Is there any one of them common in terms of this ratio? Which one and which one? This one. Cos of cos of theta. Come get d over c. Now, can you see that it means sine into 90 minus theta equals to cos theta? Can you see that? Okay. Now let's come to this one. Cos of 90 minus theta. Any one in terms of this ratio? Sine theta CD over. So can you see that cos of 90 minus theta equals to sine of theta? Now let's take tan. Is there anything looking equals to this one? So this one is not equal. So it means we can see that we can now conclude that it means sine into 90 degrees minus theta equals to what? Now we say this is what we call co-ratio. We call this co-function or the co-ratio. But as right we want to again. You see where it's coming from again. So meaning that next time if you see any angle or any sine into 90 minus the theta, it means this is going to change to cos. According to that, we see that it will be equal to that. Then now, if you see cos of 90 degrees minus theta, that will be equal to sine of theta. So we are saying this is called co-ratio, or some other books they call it co-function. But in grade 10 we didn't mention that but we just did this and mention that we didn't check the equal ratios again. So it means the co-ratio means that they are the two functions that are equal in terms of ratios again. Then we call them that. So meaning if you see this one, or anywhere you see the 90 part again, it means we are going to change the cos to sine, sine to cos again. So take note of that. You don't have to go through that way, but you just know that this can be defined like that again. Any question? So we'll stop here at the co-ratios and then